density. First thing you had to do was match these definitions with the word. So you need to know matter is anything that has mass or volume. Mass is the amount of matter in an object. Volume is the amount of space matter takes up. And density, you need to know the technical definition of the amount of mass in a given volume. But I like to think of density as how tightly packed the atoms inside of something are. So remember, if we're talking about density, something like this is less dense than something like that. Okay? So make sure you have an understanding of what matter, mass, volume, and density are, because they're kind of confusing, but if you study them, it should be fine. Section 2, you had to match or put these in their correct columns. Tell me what tool we use to measure it, the units or what comes after the numbers, and then draw a picture that shows me you understand. So remember, for mass, we use a triple beam balance, or you can say we use a scale. You can add that on there. The units for mass you need to know are grams, okay? It doesn't matter if it's kilogram or milligram. You need to know that gram is for mass. And then you need to draw some kind of picture that shows us you understand what mass is. So you don't have to copy me. If you have a scale, you can draw something like really heavy, or excuse me, really light here. We'll just make this a smaller one. And like really big and heavy here. So obviously this has a mass that's greater than the one on the right. Volume is measured with a graduated cylinder. Okay, you need to know that. Also, I would like for you to add over here for volume, you need to know that we use water displacement to find the volume of an irregular shaped object. And we'll practice that on the other side. Okay, also for volume, you can do length times width times height. So if I were you, I would write graduated cylinder, water displacement method, and the formula length times width times height. The units are milliliters. Again, it doesn't matter if it's milliliters, liters. Anytime you see liters, it's volume. A picture you can show to understand. You can just draw like a graduated cylinder and you can fill it up with liquid. That's volume. Okay, or you can say this one has a greater volume than that one. Density, we use the density formula. You need to know mass divided by volume. That will be on every test you see. If it's a liquid, the units are grams per milliliters. And then if it's a solid, it's grams per cubic centimeters. Okay? A picture that shows you understand. You can draw two objects. They have the same volume, but this one, that's my email, excuse me. But this one, you can draw the atoms or the particles really tightly packed. Okay, this is a high density. And then this one over here obviously has a low density because there is less mass in the volume. Okay? So make sure you know how to find it. You need to know the units, because on your test, if you just write 3, you're going to get points off. You need to tell us 3 grams, 4 milliliters. Okay? If you just write 6 for your density, or excuse me, 6.24, because we need 2 decimal places, it's going to be wrong. You need to add whatever unit it is. On the back are some word problems. Let's work through these together. It says, what is the density of an object with a mass of 42 grams and a volume of 7 grams? Show your work and don't forget the units. So remember, density equals mass divided by volume. The mass is 42 grams. The volume is 7 milliliters. So 42 divided by 7, that's going to give me 6 grams per milliliter. That's the density. So make sure you know how to calculate density. For this one, it says the mass of this block is 1,000 grams. The volume is, look over here, I gave you the formula. You have to know this for your test, okay? Length times width times height. So all I'm going to do is 25 times 10 times 5, 500. So the volume is 500 centimeters cubed. Alright, that's the unit. Density is what? Remember the density formula. D equals M over V. It tells you the mass is 1,000 grams. So 1,000 G divided by 500 cm equals what? You know? If you don't know, you can totally do it on your calculator. No one's going to judge you. 2 grams per cubic centimeter. So you're going to write that over here. Alright. This one, you're going to see a question like this on your test. So make sure you know how to do this. You have an egg here. It tells you the mass is 3.2 grams. The volume is, if you look over here, the one with the egg in it, you're going to read over here. You're going to read at the bottom of the meniscus. This is 10, 11, 12, 13 milliliters. That does not mean that the volume of this egg is 13 milliliters. You have to make sure you subtract it from the initial volume. So if you look at the bottom of this meniscus, the volume, the initial volume, or the first volume, was 4 milliliters. So if you want the volume of just this egg, you need to do the water displacement method. That's the one where we subtract. So you take your final volume, 13 milliliters, and you subtract your first volume, and you should get the volume of your egg, which will be 9 milliliters. So this is a bit of a multi-step problem, but you will see this type of question on your test. Now you can just do density. The density is, remember, D equals M over V. It tells you the mass is 3.2 grams. You calculated the volume to be 9 through water displacement. The volume is not 13, so you need to make sure you divide by 9. So you're going to do 3.2 divided by 9. Okay, and if you notice, this is my answer. You need to round to the hundredths place, or 2 decimal places. So I'm going to do 0.36, and this is a solid, so grams per cubic centimeters. Actually, well, we're using a graduated cylinder, so let's just do ml. Okay? This one. Remember the lab we did where we had that mysterious green liquid and you guys found the mass and volume of it? Each of you guys had a different amount of green liquid. Some of you guys had this much. Some of you guys had only a little bit. If the density of 30 milliliters of this mysterious green liquid is 1, what would the density be of the same mysterious green liquid if it had a much larger volume? Just because you have a very large volume does not mean the density change. You can have, and by the way, remember that mysterious green liquid we found out to be water. It does not matter if you have 30 milliliters, if you have 1,000 milliliters, or if you have like an Olympic-sized swimming pool. The density is always going to be the same if it's the same substance. So the density would not change. It'll be 1. You also need to be able to do a density column. This is a density column. You need to understand why some things sink to the bottom and why some things float on top. If it has a high density, it's going to sink to the bottom generally. If it has a low density, it's going to float to the top. So look at this data table. If you have a trouble reading decimals, what I like to do is I like to add dollar signs. Okay? Because now I can read this as 80 cents. I can read this as $1.40 or 90 cents or $1. So which one of these has the greatest mass, or excuse me, the greatest density? It's this one. So this one, corn syrup, is going to sink to the bottom. Which one has the next least density after that? It's water, because it has a density of 1. So water is going to float on top of corn syrup. Well, this one's a little weird. This will be corn syrup, this will be water, and then on top of water, the next greatest number is olive oil. So olive oil is going to be this level over here. Okay, this is kind of weird, but you guys can follow along. And the one that floats on the top is the least dense one. Alcohol is the least dense, so that's going to float at the top. You are going to see this on your test, and most definitely the SOL, I think. If we give you the densities, you have to be able to put them in order from most dense, that sinks to the bottom, and least dense, they float to the top. Okay, we're almost done. The density of this gold ring is 19.32 grams per cubic centimeters. That's the density of gold. The density of gold is always 19.32. If someone gives you a piece of gold and you got a density of like 8, guess what? They ripped you off. It's not real gold. So it's asking you, what is the density of this gold necklace? If this has a density of 19.32 grams per cubic centimeters, and this one is also gold, does density change? No, it does not. It's just like this one over here. The density of water is always 1. It doesn't matter if you have a little raindrop or if you have an Olympic-sized swimming pool. Density never changes if it's the same substance. So what is the density of this gold necklace? It's the same. 19.32 grams per cubic centimeter. How do you know? Because density of the same substance never changes. We use density to help us identify substances. So if I had like a random piece of shiny gold looking material and it has a density of 19.32, I know for a fact it's 100% gold. Alright? So please study this, because your test is going to be very, very similar to all of this.